Archimedes of Syracuse was born around 287 BCE in the ancient city of Syracuse, a Greek city-state located on the island of Sicily. He was born into a well-connected and educated family. His father, Phidias, is believed to have been an astronomer and mathematician, which likely influenced Archimedes' early interest in science and mathematics. Though few personal details are known, Archimedes' education and environment suggest he was intellectually gifted from a young age. Archimedes is thought to have studied in Alexandria, which is present in Egypt, which was one of the leading intellectual centers of the ancient world due to its famous Library of Alexandria. There, he may have studied under successors of Euclid, the father of geometry, and interacted with other Greek mathematicians like Conon of Samos and Eratosthenes. His time in Alexandria exposed him to a wealth of mathematical and scientific knowledge, which shaped his future discoveries. Archimedes made profound contributions to geometry, calculus, arithmetic, and number theory. He developed methods to calculate the area of a circle, surface area, and volume of spheres, cylinders, and paraboloids, often using infinite symbols, a precursor to modern integral calculus. Archimedes refined the method of exhaustion, originally developed by Eudoxus, to approximate areas and volumes by inscribing and circumscribing polygons. He defined a spiral that now bears his name and used it to square the circle and trisect angles, problems that challenged mathematicians for centuries. And its name is Archimedean spiral. Archimedes calculated pi to be between 3 whole 1 upon 7 and 3 whole 10 upon 75, an astonishingly accurate estimate for his time. In his work, The Sand Reckoner, he devised a system to express extremely large numbers, challenging the limited Greek numeral system. He imagined the number of grains of sand that could fill the universe, showing his mathematical creativity and scope. Archimedes was not just a theoretical thinker, he was also a brilliant engineer and physicist. He formulated the fundamental principles of the lever, famously stating, "Give me a place to stand, and I will move the earth." Archimedes established the concept of the center of gravity and used it to determine the balance of objects. Perhaps his most famous discovery, Archimedes' principle, explains that a body submerged in fluid experiences a buoyant force equal to the weight of the fluid displaced. Legend says he discovered this while bathing and ran through the streets shouting, "Eureka!" He worked with pulleys, screws, and levers to create powerful lifting devices. There is a machine, namely Archimedean screw, used to raise water for irrigation, still in use today in some parts of the world. During the Second Punic War, Archimedes played a crucial role in the defense of Syracuse against Roman invasions. He designed war machines such as catapults, ballistae, and cranes capable of overturning or sinking ships, referred to as Claw of Archimedes. Ancient sources also speak of his use of mirrors to focus sunlight and set Roman ships on fire. Though modern historians debate the plausibility of this, Archimedes saw mathematics as an art, and he was more interested in pure mathematics than in its applications. Despite his practical inventions, he often considered them of lesser value compared to his theoretical work. He reportedly asked for a representation of a spear and a cylinder to be inscribed on his tomb, signifying his pride in proving that the volume of a spear is two-thirds that of the cylinder in which it is enclosed. Archimedes died in 212 BCE during the Roman capture of Syracuse under General Marcus Claudius Marcellus. Despite strict orders from the Roman general to spare him, Archimedes was killed by a Roman soldier, either because the soldier did not recognize him or because Archimedes refused to leave his mathematical work. Archimedes' influence stretches through the Middle Ages, Renaissance, and into modern science. Islamic Golden Age scholars translated and preserved his works. During the Renaissance, his works inspired figures like Galileo Galilei, Johannes Kepler, and Isaac Newton. His principles remain foundational in physics, engineering, calculus, and geometry. Mathematicians still study and admire his problem solving techniques and rigorous methods. His major works are on the sphere and cylinder, on spirals, on the measurement of the circle, the quadrature of the parabola, the Sen reckoner, on floating bodies, the method of mechanical theorems. One of the most exciting discoveries related to Archimedes occurred in 1906 when a previously lost work, the method, was found hidden beneath a medieval prayer book whose name is palimpsest. This revealed Archimedes' use of mechanical reasoning and infinite series, foreshadowing calculus by almost 2 millennia. Archimedes has been portrayed in literature, film, and popular science as the quintessential absent minded genius, brilliant in intellect but unconcerned with practical matters. The story of his death, while absorbed in a geometric problem, has contributed to this image.